In this video, I'll show how to use data management for Hadoop to perform fundamental data quality operations on your data stored in HDFS in parallel on the Hadoop cluster. Now, in data management, there are several kinds of data quality operations built in. A couple of the most fundamental are address standardization and name quality. And these are seen on our palette. We have CAS certified address standardization, global address standardization, Canadian address standardization, and so on. And if you've worked with large name and address data sets, you know that even with data management's superior performance, anytime you get up into hundreds of millions of records that you want to standardize, it can start becoming a bottleneck. So like all processing in Hadoop for data management, we use the parallel section. Everything in the parallel section executes in parallel on Hadoop using a set of tasks, and everything on the outside is in the data management server. I have a name and address file already in HDFS. My large name and address file is 6 gigabytes. It's about 100 million records. If I analyze that, so I have name, address, city, state, zip, and phone. First, let's just look at address quality. I'll take our CAS certified address standardization, map the input columns, and then let's search for addresses that don't actually code. So there will be a standard status code, and the ones that don't code will get an X, and we'll output them to our output connection and send them to a viewer. So while I could run it just like this and it would be perfectly fine, the one other thing that you want to keep in mind is that address standardization runs faster when it's partitioned, when it's grouped by zip code or by city and state. So I'll add that one other thing. I'll say partition by zip code, but it doesn't necessarily need to be sorted. It just needs to be grouped by zip code. So I'll set it to segment instead of sort. Now when I run this, you'll see the first thing it'll do is run the distributed partition, because I told it to partition that input by zip code. And when that finishes, the transforms will pick up and actually do the address standardization. Alright, now that my partitioning is finished and the transforms are running, I can go to the management console and look and see all the transform projects here and actually attach them and see what they're doing. And as you can see, each one is reading a set of data, standardizing it, filtering it for standardization failure, and sending it on to the output. Now let me point out while this is running that the cluster we're running on here is actually rather puny. It has 8 nodes, each of which is an i5 and 3 disks. It basically consists of hand-me-down workstations that we repurposed and cobbled together into a Hadoop cluster. Yet I think you'll see we'll achieve some truly excellent performance on this address standardization. Now as you can see, our transforms have finished, and it is consolidating all the output into our viewer so we can look at all of the addresses that failed to standardize. And as you can see, all their status codes are X. A similar kind of data quality operation is name quality. Data management has built in a name parsing macro, and this examines a name field and parses it into multiple parts. And based on that, we can ask questions about it like, are any of these names actually double names? We can say, for example, I'll look for a second first name, and we'll output all those records that are double names. Now in this case, I don't want to have my input partitioned. There's no reason for it. I'm going to set partitioning to record, meaning that the records will be split arbitrarily and sent to tasks with no particular grouping. This will give us a better performance because the name parser doesn't really care about the grouping or ordering of the records. So when we run this, you notice there's no partition phase anymore. It goes straight to the transforms. And when I go look at my management console, you'll see that my transform tasks are running. I can view those, and you'll see that inside here I have my name parser and my filter. I can even go into here and look at what's happening on the internals of the name parser. All of these different kind of lower level operations are going on. And once my transforms are all finished, it will consolidate all the outputs to the data viewer, where I can see which of my names had double names. Now let's talk about performance for a minute. If we go back and look at our times for running that standardization project, it was able to standardize 100 million address records in about 3 minutes and 36 seconds. And that works out to nearly 500,000 address standardizations per second. And anyone who's worked with standardizing addresses, especially certified standardizing addresses, knows that it's very difficult to achieve this kind of throughput. But thanks to the scalability we get on Hadoop, we run this operation very, very quickly. And similarly, if we look at the times for the name parsing, that was about 2 minutes for 100 million records to name parse and split all of those results out into separate columns. And I think that anytime you're dealing with large amounts of contact or customer data or that kind of information, that this kind of performance is truly unbeatable.